Alright nerds, so today we're going to talk about reflection, and reflection is probably a bit more important to your life than you imagine. Basically, every image you see, everything you can see, whether it's the floor, blah blah blah, unless it gives off light of itself, you're seeing a reflection. You're seeing light bounce off that and into your eyeballs, and that's how we see. Okay, so let's get into it. The law of reflection is super straightforward. When a ray of light hits a flat reflective surface, it bounces off at the same angle to the normal that it arrived. Now, if you look down here, the normal is a line, an imaginary line, that is 90 degrees to the flat surface, so perpendicular to the flat surface. We call the angle that it comes in at to the normal the angle of incidence, which we see here, and then we've got the angle of reflection there. Alright, so the angle of incidence is the same as the angle of reflection. Or, the way we would write that mathematically is down here with theta I equals theta R. So the I is for incidence, R is for reflection. Theta is a way of saying angle. It's the way we mathematically, this is an angle. It's the symbol for angle. Okay, so if we were using a straight mirror, here is our normal. It's the imaginary line that's perpendicular to it. The incident ray comes in, and the reflected ray bounces off, and this angle of incidence here is equal to the angle there. That holds true, and that's really important. We're gonna talk about that later. But the first thing we're going to do is we're going to do experiments, and we're going to see if this holds true in reality. So theta I equals theta R, and that is the law of reflection. Alright. We are going to add a second part to it. Okay, so we've got our straight mirror. There we go, we've seen that before. If we use the three rays, the triple slit that gives us the three rays, we can see that along here, what we actually get is we get the same angles, but you've got an angle 1, 2, and 3, but they're all the same. On a curved mirror, you'll see that it basically goes to the tangent. Okay, so the normal is to the tangent. If you're not sure what a tangent is, you should look that up. So a curved mirror goes to the tangent. So we can get an image from these ones because you can see how they're smooth. If we've got an uneven surface, we get diffuse reflection, and so it's all over the place, and we can't get, they call scattering of light, and we can't get an image from that. Okay? Concave mirrors, basically, this is how to draw them. So we draw the normal off there by making the tangent, that's the word, that's a struggle, and you can predict where they're going to bend. Now, so then we draw in the reflected rays, and that should be roughly the same. So the focal point in the middle here, this is the only part I want you to write down from this one, is I want you to draw this diagram. So that's our focal point. Now, and then of course the concave mirrors cause light to converge. So don't stress about that, we'll get back to that one later on, and yeah, that's where we are. Now convex mirrors, so same story, draw the tangent, see the mirrors bounce off, and the focus, or the focal point, is behind the mirror, and I want you to draw that as well, please. And we'll get this thing. So convex mirrors cause light rays to diverge. So concave means they come in together, convex means they're going to diverge. Alright, so that's where we're at. So hopefully what we've gathered in our law of reflection is how light reflects in a straight mirror, how light reflects in the two different types of curved mirrors. Now, any words there that you're not sure of, you need to add them into a vocabulary, basically. Alright, good luck with it. I hope that wasn't too much, and I'll see you in class to do an experiment.